All right, the first electrocyclic reaction that we're going to look at is a 6-pi system. And 6-pi, you mean if you look at the starting material, so there are 1, 2, 3, 4, 5, 6 pi electrons. And we use heat. This is thermal reaction, so heat, just heat, no light yet. Okay. All right, let's read right here. So I wrote it right here. This is important. To explain the stereochemical outcomes, we focus on the symmetry of the HOMO of the starting material. Always. So we all frontier orbital, we either talk about HOMO and LUMO. Okay, so we're gonna start with the HOMO of this guy. So what's the HOMO look like though? I think you might be able to do it by now, but I'm just going through it with you. So 6p orbitals, so 6 atomic orbital will give you 6 moles, 6 molecular orbitals, and you can name them. I'm going to name them pi 1, pi 2, pi 3. This is bonding. Pi 1 star, pi 2 star, pi 3 star. This is anti-bonding. Okay, and at the bottom, the lowest, the most stable one, all p orbitals are up, or ups. Okay, the next energy level up, so 1 node. All right, so I flipped 3 of them. The next one, so 2 nodes, and it's so on. But that's all we need. So, and I'm gonna stop right here. You will see why I stop right here. I don't go all the way there. Let's fill up the electron and look for HOMO. Okay, we have 6 pi electrons, so fill it up from the bottom. 1, 2, 3, 4, 5, 6. That's a HOMO. And you don't need to go up higher. We just want to look at HOMO. Okay. All right. So the HOMO look like this. Okay. Now we are interested in the p orbital of the terminal carbons. Just these 2 carbons, just the N carbon, only because these are reaction centers. The rest, I don't care. It could be look anything else, man. I don't care. There will be overlapping between this. Okay. The new sigma bond will, if you look at the reaction, so sigma bond will form right here. The sigma bond right here, sigma bond right here. All right, this is a possibility. So the sigma bond will be formed right here. All right. So basically, these 2p orbital will overlap either red and red or blue and blue. Could be either one. Okay. Now watch what happens if I do red and red. So the left orbital gonna rotate that direction. The right orbital will rotate that direction. We call this rotatory. But you don't need to know the name. I mean, you just match the color basically. So it rotates like that. All right. Now if you can do blue and blue, rotate like that, and then overlap. Okay. So I'm gonna go this way. Now this is not the starting material yet. The starting material have the methyl group pointing out. So now I'm gonna add the methyl. Okay, 2 methyl groups on the end carbons. All right. All right. So we're gonna overlap now. So the red and red have to come together. You get that? Now you get cis product. The 2 methyl group pointing up, both of them pointing up. Okay. Now we can do blue and blue. Now the 2 methyl group pointing down, and we got that compound cis. These 2 are exactly the same compound. Okay, these are identical, so I call them meso compound. All right. So basically, 6 pi electrons electrocyclic reaction, use heat will give you the meso compound. You can draw the arrows or in a circle like that. That's a draw the mechanism. That's it. All right. All right. I'll have you do on this on your own and then check with me. Okay. So 6 pi electrons, same thing. You look for HOMO, and we just did together. So I'm gonna skip this. So the HOMO look like this. Now the methyl, one is pointing in, the other one's pointing out. One pointing in, the other one pointing out. Okay. All right. So we're gonna put the red and red together and the blue and blue together. So red and red rotate. What do you get? You get a trans. Yeah, this is a trans. And you can do blue and blue. Here we go. All right. Basically, if you draw the mechanism, so in a circle, and the product, you get either this or that. That's how that works. Okay. So summarize what we just learned. An electrocyclic reaction, nothing new, right? We look at a HOMO, and we look at just the p orbitals of the terminal carbon, the N carbon, and make them match the same color. Okay. And you can get either cis or trans, basically. All right. Next video, we're gonna look at the thermal electrocyclic reaction of 4 pi electron system. Exactly the same thing. Look for HOMO and then match the color. Okay. All right. Let's check the next video with me.